In this video, we are going to look at projectile motion. It's the movement of an object that is propelled vertically, but then is subject only to the force of gravity. We have an equation that we were introduced to in advanced algebra. In advanced algebra, we used h instead of s, but the equation was the same, negative 16t squared plus v sub ot plus s sub o. S is the total height at any point in time, how high you are from the ground. T is your time in seconds, v sub 0 is the initial velocity, and s sub 0 is the initial height. Okay, so all we need to do is plug in whatever numbers were given for each of these variables. So for example, a rocket is launched straight up from the ground with an initial velocity of 288 feet per second. Write an equation that represents a situation. So what we're going to do is we're going to plug in everything we can. So S equals negative 16t squared. T is acting as our x does, plus v sub 0. V sub 0 is our initial velocity. That's 288. Plus s sub 0. The initial height is 0 because we shot the rocket up from the ground. So this is the equation that we're writing for this problem. Then we're being asked, when will the rocket's height above the ground be 1,152 feet? So the height above the ground is s. So we're going to plug 1,152 in for s. And then we have to solve negative 16t squared plus 288. 288t, I forgot the t up here. So what we can do here is to move our 1152 over, or move the two of these over, because that'll make it a positive, and then we'll be able to see that this is a quadratic. We can then look into factoring it, or we can go ahead and use quadratic formula. So I'm going to add 16t squared and subtract 288t on both sides. So add 16t squared and subtract 288t on both sides. When I do that, I now have a positive 16t squared minus 288t plus 1152 is equal to 0. Okay, from here, I can go ahead and divide out a 16 from each term. I'm going to pull out my greatest common factor. Now, you may not have noticed that, but it's well worth doing. That's going to leave me a t squared. When I take 288 and divide by 16, that leaves me an 18t. And if I take 1152 and divide by 18, I get 72. Okay, so I have 16 times all of this. Okay, the next thing I'm going to do is to factor it down. So as I move over here to factor it, I'm going to leave 16 there, and I'll have t with t. I need factors of 72 that are going to make 18. You can run through the whole list, and what you find is that 6 times 12 makes 72, and then the 6 and the 2 will make the, or 6 times plus the 12 will make the 18. So what we know is that we can finish solving for t. We're looking for when the rocket will be above the ground. So t equals 6 and t equals 12 are the two quantities that are going to make that 0. So what that means is that our rocket, if we draw a quick sketch of this, is starting at the ground. The rocket's going to go up and the rocket's going to come down. At 6 seconds and at 12 seconds, the rocket will be 1,152 feet in the air. Okay, so our answer then for this one is going to be t equals 6 or t equals 12. Now, we can change that problem a little bit and say, when will the rocket's height above the ground be at least 1152? Okay, so as you can see, I've already got the parabola sketched out here. The rocket was going to come up and come down. When is it at least 11:52? Well, with the horizontal line there, it's 11:52 from 6 to 12 seconds. So if we write this in notation, it'll be from 6 to 12 seconds inclusive. Or if you wish to write it out in words, you could say from 6 to 12 seconds, including both 6 and 12. So in the projectile problem, what's going to be important here is knowing this equation. You will have to know that equation for the test and know what the variables stand for. Then, when you're looking at projectile problems, you're going to get this upside down parabola, and then you just carefully have to read this problem as far as greater than, less than, or in fact just equal to a certain height.